All right, so I want to do a video over the free responses you did and talk especially about, these are definitely going to be free response, and so all that you should be doing to receive points, etc., and not too much because it will be timed. So I know you can read it, so I won't read it for you. But it says EFT and hundreds of entries. That's kind of important for labeling units are shown above. It says use the data in the table to approximate the rate. So think of rate, that's the derivative, in hundreds of entries per hour at which the entries were being deposited at t equals 6. So once again, it's that famous question of, notice you were given the function e of t, and basically question A is asking you to approximate e prime of 6. That's really what it's asking. So I would label it that way. I'd say e prime of 6. Notice that I go around 6, so I subtract the y's. I put the numbers off the table. I subtract the x's. And frankly, y'all, you can leave it right there. Whatever that number is, you don't. I know it's not a hard number to get, but you'll get credit for this. But you need to label hundreds of entries per hour. That would give full credit. Okay? So know when you look at the grading standard, you don't have to get the actual number that is there. So just know that as you're looking at these grading standards. All right, part B. Use a trapezoidal sum with 4 subintervals given by the table. Kind of erase some of my writing there. To approximate the value of 1/8. Okay, so once again, everything's labeled 1/8. And in fact, I probably would just write this because the trapezoidal sum actually only approximates this part. So I'm not going to put the 1/8 part there. I'm just going to put this. And, well, I'll put the 1/8 there. Just know where that comes from. So the 1/8 comes from the 1/8, the fact that it was there. And then I do the trapezoidal sum to approximate this. This is what the trapezoidal sum is actually approximating. Now notice that it is not, they do not have equal height. So I like to just do it quickly, realize that my heights will be the difference right there. So remember with trapezoids, I can always pull out a 1/2, so I could have that. And then, however, I cannot do the first and last once and the middle ones twice because I don't have common heights. So I would do 2, and that would be 0 plus 4. That would be trapezoid 1. I would have 3, and I would have 4 and 13. I would have 2, 13 plus 21. And then I would have 1, 21 plus 23. And once again, friends, stop there. You do not have to get the number. That's what it would be. And then, of course, in part, the rest of that part says using correct units, explain the meaning of this. Well, let's talk about what the correct units were. Remember that this kind of looks like integral over interval. So it is going to be the average number of hundreds of entries. So here is what this is going to be, is the average number of hundreds of entries, that's units, in the box. And then what is the 0 and 8? What do they go to? Because remember, specific time interval between noon and 8 p.m. So again, it tells you what it is. It's the average number of entries, And of course, it's in hundreds of entries. That's the units in the box between noon and 8 p.m. So there you go. All right. What does letter C say? Letter C says, at 8 p.m., volunteers begin to process the entries. They process the entries at a rate modeled by the function P. Notice it's named. From 8 to 12. According to the model, how many entries had not yet been processed by midnight? So here's what you have to think. Remember, notice P of T is also in hundreds of entries, so that makes sense. Well, again, y'all, this is the kind of interpreting, and this is how it's going to be. You have to figure out really what they're saying. Notice how many were in the box in hundreds of entries. So there weren't just 23, there were actually 2,300. Okay, but we're going to do our units in 100 entries, so we'll just say 23. At 8 o'clock, there were 23. Now, what they process would be the integral of P of T. So read carefully. According to the model, how many entries had not yet been processed by midnight? So you would take the 23 here, this ending number, minus the integral from 8 to 12, because that would be from 8 p.m. to 12 p.m., of P of T dt. And again, on the AP test, it says that you don't need a graphing calculator. So I'll be honest, I think you could stop there. It would say set up but not solve. Obviously, on a normal test, when you had to use your calculator and do math 9, you would come up with an answer. But this part right here is not, I don't believe, going to be on this AP test, because it says that you won't have to do that. So know that that's kind of, they might have you set it up though. Okay, letter D. Letter D says, according to the model from part C, so for P of T, so I'm looking at P of T, I've got to interpret what this question is asking. That's the hardest part. According to the model P of T, at what time were the entries being processed the most quickly? What is that saying? That is asking for the absolute, this is the rate at which they're being processed. So it's asking for basically the, when that is the absolute maximum, correct? Most quickly would be the absolute maximum. So really this question is saying, in simple terms, for P of T, find me the absolute max between 8 and 12. That's what it's asking. It's a closed interval, and it's asking for the absolute maximum. So how do you do that? You, of course, do the candidates test. So you would need to find P prime of T is equal to 0. Now notice, I'm not showing you the calculator part, because I've done that before and you can go to that. You can let your calculator, you can put this into P of T and find the derivative, which the derivative is not that hard since it's a polynomial. So you could, honestly, it'd probably be faster just for you to find what P prime of T is. You would find that that's equal to 0 using your calculator at 9.184, I guess, and at 10.817. I'm going to do a candidates test. I'm looking for, it says, at what time were the rates or the entries being processed most quickly? So in other words, when is the rate the highest? So I want to plug those in to P of T. So I have my times, I have 8, I have 9.184, I have 10.817, of course I have 12, and I'm going to take those, plug them back into P of T, which here's where the calculator would be nice. Of course, you find these values and plug them back into P of T, and you get these numbers. Sorry, 0, 8, 8, I guess it could be 8, 9, sorry, that's very ugly. And then this one was 2.911, and this is 8. And then what does the question say? When is it being processed the most quickly. I'm looking for the highest number. Well, the highest number is right there. So answer the, make sure you answer the question. Entries are processed most quickly at, you can either say at midnight or at t equals 12, whichever you go there. Okay, so that is question number 1. Now let's do the next one. Alrighty. So we've kind of done one like this in class. I think this was on one of your tests, actually, something very similar to this. So hopefully you did well. It says, Karen rides her bicycle along the straight road, starting at t equals 0. Okay. And it says her velocity in miles per minute is multiplied by the piecewise under. So I like to, I know it says it up here, but my brain, I got to write it down in miles per minute. Okay, perfect. Find the accelerations of Karen's bicycle at t equals 7.5. Again, I think this question, I was giving you this before I knew what, really about the AP test. I'm not sure if the velocity acceleration will be on there, but it says find the acceleration is 7.5 minutes. Basically, I'm asking for it would be, if that's velocity, the acceleration is going to be the slope of that line there. And of course, the slope of that line is, I'm just going to take, I have these 2 points. So once again, it doesn't matter which order you subtract, but 0.2 minus 0.3 over 8 minus 7. And of course, I would leave it like that. You don't have to actually get the numbers as long as you write that difference quotient. Now, what would be the units? Well, the derivative, remember, when you have the units of miles per minute, the derivative is the rate. So you take whatever that units is and divide it by minutes. So, of course, this would be in miles per minute squared. Perfect. Part B. Using the correct units, explain the meaning of that in terms of Karen's trip. Well, you know that's just a straight formula, right? So it's that 0 to 12 of v of t with the absolute value is the total distance. That's where I got this test question. Total distance Karen rode, I should say in miles. I'll put that right there. Total distance in miles Karen rode from t equals 0 to t equals 12 minutes. Good. Find the value of that. So to find the value, the absolute value of velocity, basically what I would have to do, and again, I'm not going to take the time to actually do this per se, is I would have to find the areas of all these things. Now remember, it's absolute value of velocity, so even though this one is below, I would pretend like it was above. So I'm going to find, I won't erase all that, but I would break it up into my geometrical shapes, and I would find, 1/2 base times height, 1/2 base times height, etc., all the way across until I got to 12, and I would find, I think you're okay with me not doing that. Literally doing that by hand. But I would show that on my paper, like, okay, this triangle, 1/2 base is 2 and height is 0.2. So that one's 0.2. Well, that's the same one. So that's going to be another 0.2 because those cancel. And then, break it up into these things and you can add up. So I'm not doing the best work here. Plus ... Technically speaking, you could leave it like that as well. Okay, as all those things added up. So it ends up being 1.8. But once again, you wouldn't have to actually get to that number. Letter C. Shortly after leaving home, Karen realized she left her calculus homework at home. Karen. And she returns to get it. At what time does she turn around and go back home? Give a reason for your answer. Well, think about what that would be. It's kind of that whole moving to the right, moving to the left. She's going to change direction when her velocity changes sign. So that's Karen turns around. I'm not writing very neat. That says turns. Of course it does. Karen turns around at t equals 2 since velocity changes sign. I'll say changes from positive to negative. So she's going to school and then she's going back home. So I'll be more specific and say positive to negative. Okay, perfect. Last one. Larry rides his bike along a straight road from 12 minutes. His velocity is modeled by the function blah, blah, blah. Who lives closer to the school, Karen or Larry? Okay, so what would I need to figure out there is I would need to figure out, you got to be careful because notice that Karen, you think, oh, she lives 1.8 miles from the school because that's how far she rode. Well, no, remember she drove 0.2 miles toward the school, then went back home. And so you really have to understand that Karen, how far Karen rode from home would, how far she lived from the school would actually be from this point on. So it's like these first two didn't count because they kind of negated themselves. So she really only lived 1.4 miles from the school. So that's one mistake is people go, oh, she lived 1.8 miles from the school, and she really didn't. Now with Larry, you basically want to have his displacement, right? Because that would be, he was on a straight road, so he's going from 0 to 12 of WT. Again, you could get that in the calculator, and you would end up getting that hit is 1.6. So Larry lives 1.6 miles. And then Karen, miles. And then, of course, Karen, the whole thing with her, remember, notice that the absolute values aren't there. So her displacement is 1.4 miles. So what does the question ask? It says, who lives closer? So who's closer? Therefore, Karen closer. Perfect, perfect. All right. What else do we got? What do we got on this one? All right. Part A. What do we got? So I've got a function, twice differentiable. Okay, so that means it's continuous. The table gives the values for f, selected points, blah, 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 blah. Wonderful. Estimate f prime of 4. Oh, that's such a good one. Because isn't that like number 1? The first one on number 1? These were from different years. Wasn't that exactly like the naming the elephants where we approximated e prime of whatever number it was, 6? This is the same question. Y'all, it shows up all the time. So you have a function, f of x, and they're asking you to approximate the derivative. So once again, I would say f prime of 4. I go around 4, and I would go negative 2 minus 4 over 5 minus 3, and I would stop there. I don't even need to get a number. That's perfectly fine. And there are no units in this one, so I don't even have to worry about units. Boom. That's quick, easy points. Letter B, evaluate this and show the work that leads to your answer. Okay. Well, first of all, I want to think of this. It's like, okay, the 3 doesn't bother me. I mean, I can kind of think of that as a brick, if you will. So I can split this up. So I might write this just to kind of show my grader, okay, what am I really doing? I mean, wouldn't you agree with what I did there? We talked about integrals, you being able to kind of go down the line. Well, this one right here, I mean, you could go ahead and integrate and put 3x and evaluate. That's a box. Remember we talked about the brick? So the brick would have a height of 3 and it would have a width of 11. So that's going to give you 33. Again, you don't technically have to get that number, but you can. And then what about this one though? Well, let's think about this. Okay, the 5 is just kind of along for the ride. Think about this right here, just this piece right there in the first fundamental theorem. How would you do that, the first fundamental theorem? Again, I'm ignoring the 5. You would take the antiderivative of f prime, which is f, correct? And you would evaluate it at 13 minus, and you would evaluate it at 2. So what I end up getting, again, I know that's 33, but remember you don't have to do the algebra at all, so I'm just not going to do any of it. I do want to read numbers off the table. They do like you to do that. And so I would get this. And so I would have that value right there. Okay? And I would leave it just like that. Part C. Use a left Riemann sum with subintervals indicated by the table to approximate that integral. I would bet money that there would be a Riemann sum on some form of Riemann sum on your AP test. Remember, a Riemann sum approximates the integral. Notice the first thing you want to figure out is if you have equal intervals, which you do not. So I cannot take out a common width because I don't have a common width. So once again, I like to figure out my widths up here once I realize they're not common. Those would be my widths. Now it said I'm going to double check. It says a left Riemann sum, 4 of them. I mean, because think you have 1, 2, 3, 4. So I'm going to be using the left 4 values there. So I would do 1 times 1 plus the width of the second one is 2 times 4 plus 3 times negative 2 plus 5 times 3. And I'd stop. You don't need to get a number. Leave it alone. That's all you need right there. And that's perfect. All right. D is kind of the stinker, but look, even if you don't get all the points, you can get some of the points. It says, suppose f prime of 5 is 3 and the second derivative is less than 0 and the closed interval. Use a line tangent to the graph of f of 5 to show that f of 7 is less than 4. I'm going to stop reading because I'm going to do what they say. It's talking about use the line tangent to the graph of f. So it's talking about a tangent line approximation. What was the first step in doing a tangent line approximation? It's writing the equation of a tangent line. Notice they gave you this derivative. So you're like, well, what do I need to write it around? Well, you have to know the point and the derivative. And they told you f prime of 5 was 3. And way up here, without on my writing, you know that right here, the point is 5, negative 2. So you have a point, not that you have to write this down, and a slope of, 3. So the tangent line at 5 would be y plus 2 is equal to 3x minus 5. Just getting that would give you a point. So I know you could all do that. You pop that 2 over. And then you have your line, and that's where you plug in, sorry, that's a 5. That's where you plug in the actual value of 7. Now this, you do kind of need to figure out this number, but this is easy. 2 times this, notice that that's 4. So you're saying that f of 7 is equal to, or approximately equal to 4 by the tangent line approximation. Now, that's not what the question asks. It says, how do you know that f of 7 has to be less than or equal to 4? Remember that tangent line approximations, when they ask over or underestimate, it comes down to concavity. And that's why, my friends, they told you this. So you say, since f double prime is less than 0, think of it pictorially, not that you have to draw this. If f of x is concave down, the tangent line lies above. So it's asking, how did you know that this y value here has to be less than 4? Well, because the tangent line is going to be above it. So since f double prime is less than 0 for x's between 5 and 8, then tangent line is above the curve, thus f of 7 must be less than or equal to 4. Something like that would get you full credit. Okay? The last part says use the secant line for the graph of f to show that f of 7 is greater than 4/3. Well, once again, even if you can't get all the points, what did it say? Use the secant line for the graph of f from 5 to 8. So all I'm going to do, guys, is I'm going to look at this point and this point. That would be the secant line, correct? Now I'm going to get the slope, and I'm going to do it in my head, but then I'll write it down. So do you see the slope would be 3 minus -2 and 8 minus 5? So the slope of the secant line again, anytime I do slope, I always do it. Even I can do it in my head. I write it down. That's my dog whining because I'm not paying attention to her. Okay, so I get 5/3. So the secant line, the secant line would be y, sorry, she's distracting me, would be y plus 2 is equal to 5/3 of x minus 5. And once again, if I pop that 2 over, I would get this. And that's where I plug in the 7 because it's asking about, it's greater than that. And notice if I figure that out, I end up getting 4/3, which is surprising, the number they talk. Okay, so then notice I end up getting the 4/3 there. So f of 7 is approximately 4/3. Now again, look at my drawing. If I have a secant line from 5 to 8, and this is the secant line, wouldn't the y value of all these points be above? So here's my curve. Here's a y value that I use to approximate it. So again, since f double prime is less than 0 for 5 to 8, the secant line is below curve, thus f of 7 would have to be greater than or equal to 4/3. So that's, again, that was a tricky one. It really was a tricky one there. But try to get the points you can. Even if you couldn't get the justification, you could certainly write a secant line. You can certainly write a tangent line and get the points that you should. Okay? Oh, geez. All right. Where's my next? There it is. Okay. So here we go. What do we got on letter A? So I have the derivative of the function. Okay, the derivative of function f is defined by those things, and this is f prime. All right, it told me some intercepts here, -2, and this is a real weird duck right here. Okay, so for -4 to 4, find all the values on x at which the graph f has a point of inflection. Justify your answer. Well, this should be an easy question because you know that you have f prime, f has a POI when f prime changes, increasing to decreasing, or decreasing to increasing. Therefore, f has a POI at x equals, we'll look at my hand, there at -2. I go from, I'm decreasing, then I go increasing, and then I'm increasing, and then I go back to decreasing. So at x equals -2 and x equals 0. Those are two easy points that everybody should get. So let's look at part B. Find f of -4 and f of 4. Okay, so here's the idea of, first of all, there's one idea that you have to figure out, and again, it goes back to that first fundamental theorem. So let me just write it like this. Are you with me that if it's asking for f of, if I integrated, now notice they gave me f of 0, so that's why I'm using 0. If I go from -4, I'm doing f of -4 first, to 0, low to high, of f prime of x dx, that's going to be f, I'd take the antiderivative, which would be f, I'd evaluate it at 0, minus I would evaluate it at -4. Might have been easier if I did it the other way around, but for integrating, you might like to have it, the low bound there. So, are you with me that if I solve for f of -4, f of -4, think of moving that to the left, I would have f of 0 minus the integral from -4 to 0 of f prime of x dx. Do you agree with that? Okay. Now let's figure out that stuff. Well, first of all, f of 0 is 5, so I know that's 5. Minus, now what's the integral of this? So in other words, I need the area under the curve like this and this. And you're like, oh my gosh, how am I supposed to find that? I mean, it's like, do I have to write the equation of that semicircle? No, it told you it was a semicircle. Think wisely. Let me make a box. If I made a box right here, the width of that box is 4 and the height of that box is 2. Do you agree with that? So I would have a total of 8 in that whole thing. But I would need to take out the part that's in the semicircle because that's not really area under the curve. Now, what would that semicircle be? Well, I'm kind of running out of space, but wouldn't that be true? It would be 1/2 pi r squared, and the radius is 2. So wouldn't that be 1/2 pi times 4, or in other words, 2 pi? So I would take out the 2 pi, and once again, I'd stop there, guys. I'd stop there. I don't have to figure that out. I mean, I can. It's not that it's that hard. I would get a positive 2 pi minus 3, but I wouldn't have to do that. Okay, now for f of 4, I would kind of do the same thing because I'll do it from the integral again. From 0 to 4 of f prime of x would be f of 4 minus f of 0. So f4 is going to be f of 0 plus the integral from 0 to 4 of f prime of x dx, which in this one from 0 to 4, I'm just going to replace, just don't have to rewrite something. I would write this. Now here's the deal where on this, when this was given, of course, this was a non-calculator part and people had to do this by hand. Obviously, with your exam, they say it's all you can use a calculator, but you don't actually have to find that. I don't know how they're going to ask it. So I would just be careful. I don't know. They're very clever in how they have you do things. So again, by hand, you'd have to do a U substitution step here. So this f of 0 would be 5 plus, I'll pull the 5 out from here. If I did a U sub with U being negative x over 3 or negative 1/3 x, the du is going to be negative 1/3 dx. So basically what it comes down to is I'd have a negative 1/3, I'd have to have a negative 3 on the outside, and when I integrate x over 3, and then I'd evaluate that from 0 to 4, which is really, really yucky, and that would get me to my answer. Again, do I think there'll be questions like that? I doubt it, because you know, they know you have a calculator, so you could certainly you know, use a calculator for that. For negative 4 to 4, find the value of x at which its absolute maximum. Once again, you have to do the candidates test, but I do want to say something important about the candidates test. If you throw out a candidate, you would need to tell why. So why you're throwing it out. So if they ask me for a specific one, it asks for an absolute max, I would say candidates are endpoints and where f prime changes positive to negative. Because this guy, even though the derivative is 0, you know he's not going to be an absolute max, because the function is increasing and he's going to keep increasing here as well. Now that's another thing with this one, is that you can totally defend this. Like, I could go about the candidates test and go, okay, let me plug this in, and I could certainly do that. I've already found f of negative 4 and 4, but I would have to find at this point as well. But you guys, let me just explain something. You can also justify your candidates. I just want to show you something. Let me do it this way. Sorry, not 0, whatever that weird one it was. That 3 ln. Oh my goodness, what's going on here? Sorry, my hand's hitting the 3 ln of 5/3. So my point is, if you were to plug it in, okay, notice if those are my candidates, I could find these values, which I kind of technically already have for these two. So if you know those numbers, but my guess is, since you don't have to figure them out, you might not actually get those numbers. If you want to justify with words which one of those is the largest, that's fine. You can say, since f prime is positive from, again, use intervals, since f prime is positive from negative 4, you know what, I'm going to do it like this, be faster, from negative 4 to negative 2, and negative 2 to that ln, say all up here, ln of, what is that number? 3 ln of 5/3. Well, what does that mean? Well, if that's true, then f is increasing from negative 4 to 3 ln of 5/3. So that means f of 3 ln of 5/3 would have to be greater than f of negative 4, right? And then if f is then decreasing, and since f prime is negative from 3 ln of 5/3, my is so messy, to 4, f is decreasing from there. Well, what does that mean? Well, therefore, f of 3 ln of 5/3, if a function is decreasing, would have to be greater than f of 4. So I just said that it's greater than, this y value is bigger than f of -4, and it's bigger than 4. Therefore, absolute max occurs at x equals 3 ln of 5/3. So I want you to be clear. It's like I use the candidate test. It's kind of like what we did. Remember when we had like an open interval and you had to use words and use the domain? It's kind of like that. You can justify a candidate's test with words if that is easier for you. So you certainly just know that you can do that. Okay, last one. Slope fields. Okay, on the axis provided, sketch a slope field for the given function at the 12 points indicated. Okay, so you have that. Well, again, you want to do it quickly. The first thing I would notice is, well, if x is 0, then my dy dx is going to be 0, so I'm going to have a horizontal all along here. Perfect. And in the same way, if y was 2, this factor would be 0, so these are going to be flat as well. So those are pretty easy to figure out. So I really only have, a few points to figure out. So I can plug in 1, 1. I mean, so literally I'm going up here and figuring out, well, if this is the point, well, I'll do an easier point. If this is the point 0 for x, 1 for x and 0 for y, do you see that I have a slope of -2? So I kind of draw that. And then this one, if I had the point 1, 1, I'm literally doing this in my head. And if you want to write it down, when x equals, my bad, point and dy dx. Let me do it like that. So if my point was 1, 0, like on that last one, I plugged in a 1 for x, so 1 to the 4th is 1, and 1 minus 2, I can't subtract, or 0. Man, I'm having a hard time plugging in points, guys. And that gave me the -2. Okay, let's see if I can be better. If I do the point 1, 1, I would have 1 to the 4th, and of course 1 minus 2, so that's just -1. So this guy, I might redo him because they do kind of it's all about, I'm trying to talk and think at the same time and it's not doing well. It's a comparison game. So we want this guy here to be steeper than this guy. So I have that. Now if I go to the point 1, 3, I'd have 1 to the 4th, which is just 1, and then 3 minus 2, so that's a slope of 1. This guy's going to slant like this. And again, I'm just going and plotting those points. It does take a little time. This one, you can kind of go, wait, that's going to be the same as this one because the fact that I put in -1, 1, the x is being raised to the 4, so that's not going to change. So I can kind of outsmart it and go, oh, these I'm just copying. These are going to be exactly the same as these guys. And that would be my slope field. Okay? Part B. While the slope field in part A is drawn only at 12 points, it is defined for every point in the xy plane. Describe all the points in the xy plane for which the slopes are negative. So basically I'm asking, okay, these are only 12 points. How do I know? So I'm just interpreting the question. How do I know, like this line was positive and this is negative? How do I know down here, are they going to be positive or negative? Or if I go to points out here, are they going to be negative or positive? Well, let's think about this. Wouldn't you say, well, gosh, let's just look at the function. X to the 4th, that's always going to be positive. So really it comes down to if y minus 2 is positive or negative. Well, you can figure that out. Slopes are negative. if y is going to be, less than 2, wouldn't it? In other words, how I got that, I said y minus 2 is less than 0, and I got y is less than 2. Now you have to be careful because you go, wait a minute, this y was less than 2, but I didn't get a negative slope. So you have to also say, and x cannot be equal to 0. That's why you have some lines like this that are horizontal. So you have to make sure that you say both of those things. And then part C, which if I were betting, I would bet there would be one on this. Y'all, if they say find the particular solution to a differential equation, that means separate the variables. That's going to be your first thing, your first step. So I'm going to go back up here. If I separate the variables, I get this. Correct? So this is from our last unit that you kind of learned on your own. So it should be fresh. So that's good. So that's step 1. After I do that, I'm going to integrate and integrate. So I get natural log of the absolute value of y minus 2 is equal to 1/5 x to the 5th plus c. Make sure of a couple things. First of all, you have to stick those absolute values. Second of all, you have to put the plus c right there. Now this is the one where yes, I have an initial condition, but I actually don't like doing that until, being that I get the natural log on the left. Remember, I like to solve for y first. So that's in my next step where I did the e to the thing. And here is where I can drop the absolute values. Now, I'll put in both steps just so you can follow me, because I didn't really, wasn't with you live. The absolute value, this would be e to the all this. I'm going to use my laws of exponents and say, what I'm doing is, if I have x to the 3 plus 5, isn't that the same as x to the 3rd times x to the 5th? I mean, usually you're going this way. You go, oh, that's x to the 8th. Well, I'm just undoing it. So this is e to the something with a plus, so I can multiply. And this thing becomes your big C. It is different from this C. And that's when you can drop the absolute value. So you'd have y minus 2 is equal to all that stuff. Okay? So in other words, y equals 2 plus ce to the 1/5 x to the 5th. Then I would use my initial condition. My initial condition says if I put in 0 for x, I should get in 0 for y. So what is this c? Well, that would be -2, wouldn't it? So what's my equation? I go back to this line right here where I plugged in the initial condition, and I put in the c value I got. And this is my final answer. Okay? To me, the scoring guide had a lot of extra stuff. This would get you full credit, and I think you would like it that way. I know that was a lot, but hopefully you skipped to the ones you needed, and peace out.